Hey everyone, today we're going to be looking at the difference between percentage and absolute error. The focus for this is to distinguish between what percentage error and absolute error does in terms of demonstrating practical applications. More particularly, I would say I would like to spend a little more time to align this with what we have always been doing with our MYP Criterion D tasks. Generally, if you look at the strand in Criterion D, there is a strand that basically says that you are expected to explain the degree of accuracy of your solutions in a particular real-life situation that you have been given to you. Now, so having said this, obviously there are many ways to look at what degree of accuracy is, because it is very contextual. So what I would like to use today's video to show you how we could use absolute error and percentage error as perhaps one of your ideas that you would like to use when it comes to explaining the degree of accuracy of your solutions as well. Okay, so let's really dive deep because I really want to keep this video short and sweet for you, and hopefully this video will be beneficial for you in terms of enhancing the quality of your work in Criterion D tasks. Okay, all right, so what's the difference between absolute and percentage error? I think that's really what we need to know, like knowing the definitions, and I'm going to use some specific examples to show the difference, and we're going to also look at what degree of accuracy is for those who may still struggle understanding what that really means in the context of Criterion D, which is basically applying mathematics in real life context. So let's have a quick look at this. Now, what is absolute error? All right, so basically absolute error is the difference between a measured value and the true value, okay? And this value will always be a positive value. Now, just think about what we have done with absolute value. We do know that absolute value generally would be the distance between a point from the origin, which always gives me a positive number. So that's why when we look at absolute error, the answer should always be a positive number as well. Now, we'll dive into some examples shortly, but we'll go into some of the definitions first. Then I'll show you what really distinguishes between absolute and percentage errors shortly. Percentage error, generally from the word percentage, obviously the answer is going to be in the form of percent. And what it does is to measure the absolute error, which what I have explained earlier, as a percentage of the true value. Okay, so we want to find out in relation to the true value, how much of that number is the absolute error. Okay, and there is a big difference in why we use the absolute and percentage error, because it really comes with different circumstances. Again, like I said earlier, I'm going to show that to you shortly. Now, so basically absolute error, like I said, is just the absolute value of taking the measured value, subtracting the exact value. Now, again, if you take the exact value, subtract the measured value, it would not make a difference, because the absolute value sign is always going to make that value to be a positive number. So whether you do exact value, subtract measured value, or measured, subtract exact value, it wouldn't make a difference in this case. Okay, so that's the absolute value, which obviously going to give you a raw number. And percentage error, like I said earlier, is just basically taking the absolute value, absolute error, divide by the original or the true value, and you multiply that by 100, because we're looking at in the form of a percentage. So that's why you multiply that by 100. Okay, now, so why do we need to know this? I think this is important. Okay, like I said, besides enhancing the quality of your work in Criterion D, what we really want to know is to be looking at several ways to explain the degree of accuracy of solutions when you approach your Criterion D task. Okay, and again, it really kind of enhances your ability to analyze data, to do some interpretation of your results, and to communicate your findings effectively. Okay, so let's really get down into some details here. But before we do that, distinguishing between the absolute and the percentage error, I think we first need to go back to the foundation of what you know about degree of accuracy, especially when it comes to looking at your solutions in any Criterion D task. Okay, now, so what basically degree of accuracy is when it comes to looking at your solutions is really looking at how precise your calculations or measurements are. Okay, so you could have done some specific calculations, you could have created a model, and you want to know how accurate those solutions are. I want to know how precise they are. So there are several ways to be looking at this when it comes to degree of accuracy. I think most importantly, you should be looking at the difference between precision versus accuracy. Okay, so what does that actually mean? Now, accuracy is basically how close a measured value is to the true value. Okay, that's what accuracy basically means. And precision is basically looking at the consistency of repeated calculations or measurements. So you could be doing an experiment, and you want to see how consistent those results are and how precise. What it really means is how precise those results are. So trying to know the difference between what accuracy means and what precision actually means as well. Okay. Now, when we explain the degree of accuracy of solutions, one possible way to look at this is to look at the significant figures, or sometimes we look at the number of decimal places that we use in our calculations, measurements, or even a model. Okay, these are the very, very common answers that we usually see in Criterion D, or maybe I round my answers to like 3 significant figures because that increases the precision of my measurements. Okay, that is one way to look at how we could explain the degree of accuracy of solutions. Because it is important for us to indicate the precision of our measurements. So we tend to use significance or decimal places, but it's not exhaustive to just simply these two things. Sometimes we could even look at, maybe it might be worthwhile looking at rounding your measurements or calculations to the nearest whole number. Again, it really depends on the context of the real life problem as well, which I'm going to come to that again shortly. In general, we know that the higher number of significant figures, you should get a higher degree of accuracy because you're retaining most of the digits in that number. So it kind of makes sense that the accuracy would be higher as well. So a 5 significant figures is obviously going to be more accurate than an answer that has only 2 significant figures or 2 significant digits in a way. You might say, why not just keep the values that I have gotten from my calculator? Generally, yep, that obviously is going to give you a more accurate answer, but do we really need that many significant digits, or do we need that many decimal places? Again, it is very contextual. Okay. So like I said, this is really the main part. I think how you choose to explain your degree of accuracy, it's really based on the relevance of the context that's been given to you. Okay. So for instance, I'll give you an example here. Let's say if you do any scientific measurements here, all right? Generally, scientific measurements require a very, very high degree of accuracy. But if you look at some of your day-to-day calculations, do you really need that high degree of accuracy? I don't really think so, all right? If you measure your height, all right, you probably be looking at about 2 decimal places. You don't go beyond 2 decimal places. If I'm 1.85 meters, would you be looking at my height to be 1.8526 meters? Which I don't think really makes too much of a difference between these two values. It's a very marginal increase, but it's probably not going to be observable by eye or something like that. So that's something that you really have to think about when you start looking at degree of accuracy. So now, we just talk about absolute error, we talk about percentage error. Now let's see how we can actually incorporate this into as perhaps another tool for you to explain the degree of accuracy of your solutions. Okay, I think that's important. When you're given more tools, you're probably given a little more autonomy to look at how you could write your answers, explaining the degree of accuracy, not just simply limited to just using significant figures, decimal places, or even looking at just simply the context. So I'll show you how this works. So when to use the absolute error, I think this is important. If you know when to use it, you will be able to apply it. Now, so when we deal with small consistent measurements where the magnitude of the error matters. Now, I know it sounds quite vague. Let me give you a little example here first. Now, let's say if you're given a little task of measuring the diameter of a small coin, okay, for whatever reasons it is, okay? Now, let's say if you measure the diameter of this coin, which is about 2.5 centimeters, but the actual value of the diameter of the coin is actually 2.54 centimeters. Now, we know that in this case, the absolute error is going to be 0.04 centimeters, okay? Again, this is going to be a positive number, all right? Remember I said absolute error is always going to be a positive number. So there is a difference of 0.04 centimeters. Now, this value is going to be really crucial when we're talking about a small coin because it makes a difference to the size of the coin as well. Now, looking at the percentage error, probably is not going to be that useful because in this case, we know that how the coin is going to look like with that difference of 0.04 centimeters is going to make a difference because the coin is generally really small. So that difference is going to be obviously quite, it's going to be crucial when you make any analysis about the coin or something like that, okay? So, and the next thing I do want to talk about is when the actual measurement is actually important. I think that's really where you need to start looking at why the absolute error is so important about this, okay? And I'll try to illustrate this with a little example here, and hopefully this gives you a better idea of how this works, okay? And shortly later, I will also explain how we basically use the percentage error. And first, let's talk about why sometimes the actual measurement is important. Now, let's think about this from a different scenario here. Now, let's say if you were to produce a machine part, okay, that is of a certain size, okay? Let's say, I'm just going to come up with a random number. So let's say if the machine part is 18 millimeters, okay? But it was meant to be 18 millimeters, but maybe that machine produces that part and it creates a new dimension. Let's say it was 15 milliliters. Now we know that the absolute error is going to be 3 millimeters in a way. Now, does that 3 millimeters, is it crucial? It is critical for sure for quality control. So regardless of what that percentage error is, this actual measurement is going to be so important. Okay, again, there is a context here because of the machine. If I produce a part that is smaller, all right, can you imagine like if I have a little chip that's needed for your iPhone or for any phones that you use, any smartphones, and the chip turns out to be like 3 millimeters bigger or smaller, it's never going to fit into the phone. And that's where we're going to have a little problem here. So that little difference in measurements is going to make a difference. And that's where I'm saying that the absolute error will be important more than the percentage error. Reason for that is because in this case, we're looking at quality control. We're looking at compatibility of the phones and the parts as well. So that's where absolute error, it is important for this. Okay. Now, I know it's a lot of talking on my side. I hope this makes some sense to you. But I think it is important for me to explain when to use the absolute error. So when you think about a real life context that's given to you, think about whether is it important for you to do a calculation on the absolute error and to maybe even talk about why your answers or your measurements or your calculations are a little far off from the actual value. Is there a context given to you as well? Think about all these before you decide whether to use absolute error when it comes to explaining the degree of accuracy of your solutions. Okay, now, so let's move on to the next part, percentage error. Okay, this is a big concept again. Now, but how we use this is quite different from the absolute error. Okay, now firstly, when we use this is basically when we do a comparison of errors, when we have measurements of different magnitudes or scales. Okay, now I'm going to give you an illustration here because this is going to make a lot of sense to see the difference why we don't use absolute error, but in this case you use the percentage error. Now let's say we're looking at the comparison between the heights of two plants. Okay, let's call it plant A, plant B. Now I'm just going to come up with random numbers, but these numbers are made up so that you see that difference of why percentage error is so much more critical than the absolute error in this case. Okay, now if you look at plant A, it was measured to be like 50 centimeters. Let's say after 2 weeks you want to look at the height of the plants, it was 50 centimeters for plant A, but the true height was 52 centimeters. Okay, so obviously when you do some measurements of anything, there's always going to be some measurement errors, whether it's a parallax error or whether it's just using not measuring accurately with a ruler or something like that. So you have the true height to be 52 centimeters while the measured height was 50 centimeters. Plant B, measured height was 150, but the true height was 152. Now if you look at the absolute error, both are 2 centimeters. Okay, is there any difference when the absolute error is different? You might say no, because the difference between the heights is only 2 centimeters. So how are you going to make any comparisons when the difference when it comes to the absolute error is the same? So in this case, we don't use the absolute error. We use the percentage error. Why? Because the heights are different in general. Okay, so the percentage in the difference of the heights will obviously be different as well because the numbers are different. Now, so let me show you how these calculations are done. Now, we know that to find the percentage error, we first find the difference between the measured height and the true height. So the difference for both plants will be 2. But in plant A, if you look at this, the true height was 52. So we remember the formula for percentage error is you take the difference, divide by the exact value, multiply by the 100%. So we take 2, divide by the actual value, which is 52, times 100%, that gives me like 3.85%. And we do the same thing for plant B, you get 1.32%. Now look at the difference. That's almost more than 2% difference between plant A and B. So what can we actually conclude from this? All right, we know that plant A has a larger percentage error, which means that it's less accurate as compared to plant B because the percentage error is higher, right? So obviously it's less accurate. And this is based on the fact that we are looking at this comparatively to the size of the measurements of the two plants. Okay, so one is obviously bigger, one is obviously lesser. One is because if you look at plant B, all right, the measurements are higher. So even if the difference is the same, all right, if you think about this, if I take 2 divided by a really large number, the percentage is certainly going to get smaller than you taking the same difference divided by a smaller number. Because if you think about fraction, if you have a number divided by a smaller number, it tends to give you like a bigger result as well. So that's why plant A has such an inflated percentage error, because the heights were shorter as compared to plant B. Okay, so that's why I say the percentage error is so important here as compared to the absolute error. Okay, so hopefully this gives you a rough sense on when to use the percentage error. Again, we need to look at the context, but you need to look at the data that's being given to you at the same time as well before deciding which one to use in this case. Okay, all right, now so I have explained how to use the absolute value, how to use the percentage error. in terms of practical applications, especially more particularly in the MYP, especially in the Criterion D task as well. Okay, now, so we're going to go down into some calculations. We're going to work on how we use the absolute error, how we use the percentage error, and I want to give you a little question here, and let's see if we can actually work this out and try simply to apply the formulas as well. And this is also linked to what we have done in the previous class with the lower and the upper bounds. So let's see how this works out for you guys, okay? So it says that Alan wants to lay carpet on his 4.2 by 5.1 meters lounge room floor. He estimates the area by rounding each measurement to the nearest meter, okay? So in this case, the 4.2 meters is probably going to be rounded. So let's try to figure out what is Alan estimate of the lounge floor area, okay? Now, so I'm going to get my pen out first, all right, and let's do this. All right, part A. So Alan estimate of the lounge area. So we know that 4.2, if you round this to the nearest meter, that's going to be 4 meters. And if you round this to the nearest meter, that's going to give you 5 meters. So it's just going to be 4 by 5. That's going to give me 20 meters square. So that's his estimate, okay? Rather than just looking at 4.2, 5.1, because 4 meters is reasonable, all right? 5 meters is reasonable from a mathematical perspective. It makes the calculation so much easier as well. But contextually, this becomes a little problem, okay? We come to this shortly. So now, if you're going to lay the floor with a carpet, okay, and it's going to cost you $39 per square meter, it says find the cost of the carpet using Allen estimate of the area. Okay, so we got the previous area, which is 20. So we're going to take 20 times 39. Okay, that's going to give me $780 to lay the carpet. So I want you to think about this. There is context here. I'm going to lay a carpet on the floor. But remember, instead of using the actual measurement, he decides to round down the measurements in this case. That's going to cost him $780. Now, part C, if we find the actual area, let's see what difference does it really make to lay the carpet if we use the actual area. Okay, so if I take 4.2 times 5.1, that's going to give me about 21.42 square meters. Okay, now there's a difference of 1.42 square meters for the area. So but what we're going to be looking at in part D is not looking at the absolute error. We're going to look at the percentage error. Okay, now percentage error, we're going to be looking at taking, okay, I hope you remember the formula as well, is to take the true value, the measured value minus the true value, and you divide that by the true value multiplied by 100, okay? So we're going to take, in this case, the absolute error first. The absolute error we found earlier was, I'm going to do this, I'm going to take 20 minus 21.42. This is basically the absolute error in terms of the area. You divide this by the actual area, which is 21.42, times 100%. Okay, so that's the percentage error. Put this on the calculator, you're going to get 6.63%. That's quite a significant amount of error in terms of the carpet here. So part E is basically asking, will Alan have enough carpet to cover his lounge room? Of course not. All right. And again, the question is, how should he have rounded the measurement? So instead of rounding down, he should have just rounded up. All right. It's better to have more than less carpet if you want to do it for the lounge room, because if you don't have enough carpet, all right, you could obviously argue that if I round up, I might have excess carpet. That might lead to a waste of resources and for money as well. That could also be something to consider about. Maybe the accuracy could have been, instead of even rounding to the nearest meter, we could have looked at maybe just rounding to the nearest hundredth, or maybe to a slightly, rather than just rounding up, we should have considered other forms of rounding in this case. But in this context, we are really not trying to solve the real life problem, but what I'm trying to show you is how we could quantify the absolute and the percentage errors in this case. Okay, all right, so hopefully, I know it's a rather long lesson, but I hope it is a very comprehensive one to distinguish the difference between these two errors here. All right, and hopefully if you like this video, always hit the like button. Okay, any videos you would like me to make, just always drop me a message, and I look forward to making another video for you guys. And thank you for listening, and I'll see you guys very, very soon. Take care.